So now that we have a tool crib, we'll go back into the machine and I will set my tool crib default as soon as I find it. I have the post processor. Alright, so we'll come back down to the turret, tool crib 1. We'll switch that over to the VF3. I'll save that one, go back into the mill. Now it will default to whatever's in that tool list. Alright, so at the very least I will have those 8 tools, and anything that Cam or Camworks decides to add on to the end of it, I can choose to retain or to remove from the list or integrate it into the to the mix. But it gives me the opportunity to select those tools that I preloaded and override any of the automatic feature recognition selections. Alright, so the next thing we'll start looking at is some of the operation parameters. Sort operations I don't really do too much with. This is kind of the order it's going to look for things, so face mill, entry, various operations. So unless you really have a reason to change those, probably not. Mapping the mill features. Alright, so these are settings within the TechDB. It's going to go look for that category and apply it. Where I'm really working to get down to is going to be the default operation parameters and the settings. So when we're looking at a bore setting, then we would see everything over here. What I'm looking for is default for, well, we set up for the face mill. Let's go ahead and do the face mill, and a default inch face mill operations. Is it defined by the library for the feeds and speeds or the tool? So I'm going to switch over to the tool and we'll link it to the tool. So since I can select my 3-inch, it should populate that out if it doesn't automatically. And as I build in and I teach the TechDB more of what I want, more of how I like to machine, a lot of these operations will start coming in correct or a little bit closer to what I want. And my other option was to go by operation, which would set it for all different sizes of face mill, fly cutter, would always set it to whatever the parameters are in here. Enable corner slowdown for sharps. We're not really doing anything there. Feed rates also should be picked up from the tool. Arc feed rate overrides. Basically in the anything that's going to create a tool deflection and needs to slow down the arc, we can lower it down by a percentage or to a hard-coded number. Step over for the facing, number of cuts, setting it to automatic. By default will be 1, but if it, if we have a 6-inch wide part, then it will probably make 2 to 3 passes. If we equalize the tool loading, that will kind of even out the step over distances. Machine 2 feature extents, bounding box. If there are any islands, you want to keep 10 thousandths away from the island and the XY. No bottom allowance. First cut amounts. Pay attention to we are in inch. If the percent signs are lit up, then it's going to be a percentage of the tool diameter. Direct control, cut angles, back and forth, doesn't really matter. Climb, conventional, zigzag. If we wanted to tell it to do, let's see, out to in. The other one would be to just have it go, I can't remember what that, well, zig. That it would go, it would pick, cross the part, pick up, move back, set down, go through. NC, rapid plane, and once we start into the operations, the top of stock, top of feature, those are going to start making more sense because we can have various rapid and clearance planes to work from. Feed plane is previous machine depth. We're not doing anything with the rotary. And if we want to have to pick up, so like we did the zig, instead of going all the way up to the clearance plane of 100 thousandths, we could set it, hey, you just cleared, come up 30 thousandths since we're maybe taking a 10 thousandths part. That also has a certain amount of inherent danger in it that, oh, didn't realize that section of the part was a little bit bigger and I just rapid through it. So be careful with those rapid between features. Lead-ins and links, feed moves, thresholds. I mean, there's a lot of settings that we're going to see, and this is where we're going to find the defaults. So my general comment is that after we've set up a number of operations, we've gone in through a few programs, and we find that we're changing these things regularly to get a program that we want, that we're how we're used to machining. Then we'll come back in here and we'll locate this operation and update these defaults. So I'm not seeing anything too much in here, so we'll go ahead and save the changes that we made. That writes it to the TechDB, and then we can go on to the next. All right, so the operation parameters are going to be things like face, the mill operations, any of the pocket operations, just a variety of the tools we have in our at our disposal to machine these parts. All right, so rapid, top of stock. All right, so the setup default setup parameters. The rapid plane is the top of stock, and clearance is top of feature, and then the Z limit's top of feature. It's going to be fine. So we only have condition 1. There was somewhere in here that on a lot of the operations, and we'll have to identify that in the program and the setup, a lot of these operations I would set to a kind of a global, I'm having trouble remembering that terminology. It's set to a global default that was set for the program. So you could start off a little bit higher, and as you got it more efficient, lower it down and get a lot closer to the part. All right, so default feature strategies, what it's going to go look for. Really nothing in there that I want to mess with too much. Multi-stepped holes. All right, so if you wanted to build out a port type geometry, we could go through on this multi-stepped hole, set a default that maybe our geometry has a 5/8 bore, and then it goes to a 1/2-13 threaded hole, and then to a 3/8 through hole, and we could build all of the operations, so a spot drill, a drill, an end mill to come in and relieve it, the tap drill, the tap, and do all of those operations included in this multi-stepped hole. So there's a lot of horsepower in there you can take advantage of to generate those operations very quickly. Alright, so while we're here, let's go ahead up to features and operations. Now we're getting into the really heavy duty, this is the logic of the software. So take a couple of, using the swimming analogy, get your toes in, get them wet, but don't go making super broad ranging changes to our features and operations. So let's see, we're dealing with the face feature. So there's going to be a condition, and if we look through this, what are the widths, and then when we come to the face mill, whatever is available for the operations. If there were multiple operations, it would stack them up here. And what are the attributes of that operation? So the conditions, feature depths, and largest, smallest, boxes, largest, smallest, what kind of tools will be selected, and we can build in logic of we don't want a tool bigger than, and operational depth, and operational parameters. So I'm staying with the face mill mainly because there's not a lot of settings to really work with, just to kind of introduce the geometry. So if I go over to Let's just pick that rectangular boss. We're going to see a few more. Alright, so depending on the size of the boss, what size tools it's going to default to, and right now it's set to constant diameter, and we could write, basically what type of tool it will look for, what it'll select, and then you get into some of the logic feature depth plus 0 so that it knows where the bottom of the part is. Same thing with holes, countersunk holes, counterbore holes. They will all come with a certain amount of the operational IDs, and as we create and save our working operations back to the database, those will start to get saved and become more, will come online to be able to use in the programs. So if we go back over again the multi-stepped holes configurations, and then if we actually look at the multi-stepped holes, these are the operations that are going to be performed going in and selecting. So center drill, what center drill, how big, based on the items in the TechDB, and then a drill, and then basically a countersink, and then still a drill, should still be a drill operation for the threading. Right, and then the thread mill operations, depending on what thread. If you need to set up a custom thread, then we're going to create all of the parameters, major diameter, minor diameters, pitches that are going to be included. How are we going to open up the hole? Is it going to be a drill? Is it going to be a circular mill, a profile mill, pocket mill? And then how is it going to enter and exit the hole? All right, so get familiar. It's a little intimidating. When I first started looking at the TechDB, it was very intimidating. There's a lot of information there. Figuring out where everything goes and what it's doing. Main thing is be able to set up a machine, set up a tool crib, and find your way to the defaults as you start to change and see the things that you want to actually act as defaults.